Okay, so sometimes what happens is it doesn't really make sense to find the area of top minus bottom because it looks kind of weird because it's all one curve. So in this case, instead of doing that, what we're going to do is we're going to look at here, which gives us a dy, and we've done areas with dy. So it's dy, and now it is, since we're going, this is our distance here, positive is this way, we have y1 minus y2 as our height, and delta y as our width. So we'll do an example here. This one you could actually do both ways, but we're going to do it as we could do it either as dy or dx. We're going to do it as dy. And so we have y equals x squared, which is this graph here. And I have x equals y squared, which is this graph here. And what I need to do is, it's pretty obvious where the points of intersection are, but I really want to know where they are. So I want to know when they're equal. So if x is y squared, I want to know when is y equal to y squared squared, because I'm going to plug in this y squared into here. So that tells me when is y equal y to the fourth, or when is y to the fourth minus y equal to 0. And that tells me y times y cubed minus 1 is 0. So the points of intersection are 0 and 1, which are pretty obvious from the graph and from what we know, but it's nice to know that that's the interval that we're looking at. So I have one graph. I have this one here, which is x equals y squared in terms of y, but I need to make this one in terms of y as well. So I have y equals x squared, but if I want to make it x as a function of y, it's x equals the square root of y. And in this case, I only want the positive part. This is a negative part. I want the positive part. And I know when I'm going x minus, or right minus left, I know that this one, which is x equals radical y, right here, is, because here's a negative part, I only want the positive, x is going to be my positive, and I'm going to subtract y squared. So it turns out that my integral is from 0 to 1 of radical y minus y squared, all dy. And so this is not that hard. Probably want to write y as y to the 1/2. I can integrate it. It becomes y to the 3/2 times 2/3 minus y cubed over 3 from 0 to 1, which is 2/3 1 to the 3/2 minus 1 cubed over 3 minus, and the rest of that is 0. And so it turns out that that area right there is 1/3. But you can see how sometimes this one we could have done either way, would have gotten the same area, but sometimes you want to do dy and sometimes you want to do dx.